Okay, Integrated Science, this is Mr. B with our last, officially, again, after triple checking this time, our last video of the year, again, the Expanding Universe Part 2. I mean, the last one talking about the redshift and how that's evidence that planets are universes and, or sorry, not universes, galaxies are moving away from one another because the universe itself is still expanding. And so we're going to kind of end the year on kind of it's almost a little bit poetic. Ending the last video on how everything in our solar system, everything we know to be, everything we study actually came to existence, and what is called the Big Bang Theory. So, the Big Bang Theory, again, is our best current explanation. Again, a lot of people get up in arms when they hear this word, but there really is evidence to support it. Again, it's not a perfect explanation. I don't think there ever will be a perfect explanation for how the universe itself started, but this is the best one we have based off of our current knowledge within our capabilities to explain where in the heck did our universe actually come from. So astronomers theorize there that the universe came into being at a single moment in an event called the Big Bang. Again, that redshift, the fact that almost everything is moving away from Earth, again, everything is moving outwards, is support that, again, it was created in one event. And there's also this thing called a cosmic microwave background radiation, which is our second piece of evidence, again, along with the redshift, to support the Big Bang Theory. And they not just support it, they strongly support it. The correlations there are something we really can't ignore. So the motions of our galaxies indicate that the universe is expanding uniformly, meaning again, it's not just growing out of one side or one area, it's growing the same in all directions. The Big Bang Theory states that the universe began in an instant billions of years ago in one enormous explosion. So that is kind of, again, I definitely write that down. So that's what's stated in the Big Bang Theory. So why do we believe this? So what evidence do we have? So here's just before we get to, before we get to the evidence, I kind of have a timeline of kind of what the steps that were taken there during the Big Bang. Again, in summary here. So again, the universe expanded and cooled down after the Big Bang. Again, after that one big explosion, then after a few 100,000 years of expansion of it getting larger, the universe cooled off enough for atoms to form. Then gravity pulled atoms together into gas clouds that eventually evolved into stars eventually evolved into stars inside of young galaxies. And then the next step was the sun and the solar system. They formed about 4.6 billion years ago, when the universe was about two-thirds of its present size. So, uh, 4.6 billion years ago is when we think the Earth was formed, and our solar system. And again, they're going to kind of have some numbers that, again, they mean the same thing, but they'll be a little bit confusing here in a second there. Um, oh, yeah, right here. So it says right here, again, I always like to point with my finger. It says the solar system and Earth formed about 9 billion years after the Big Bang. So, again, don't get confused with that because the Big Bang uh, was about 13.7 billion years ago. Take 13.7 minus 9, then you get that around that 4.6, that 4.7, from when our solar system formed there. So again, I had to do a double take the first time I saw that because it almost made it seem like Earth formed 9 billion years ago. Earth did not form 9 billion years ago. Earth formed 9 billion years after the Big Bang. Again, the Big Bang was 13.7 billion years ago, meaning that the Earth and our solar system formed about 4.6 billion years ago. So our first stars and galaxies formed 200 million years after the Big Bang. Again, the Big Bang itself was around 13.7 billion years ago. So again, don't get confused with those numbers there. Again, I think it's a little bit deceiving there. But again, Earth itself, 4.6 billion years ago, is when it formed. Um, so evidence. So that's kind of our timeline of how we think the Big Bang went about, and again how it leads to again a formation here on Earth, because that's what we care about. But the evidence in 1965, there's Arno Penzias. Again, probably not saying that name wrong or correctly, but you guys will have your own pronunciations for it. And Robert Wilson used a radio telescope. They noticed a faint, distant glow in every direction. So everywhere they looked, they noticed this faint, distant glow. Today, we call that glow cosmic microwave background radiation. Um, this glow is energy produced during the Big Bang that's still traveling throughout the universe. So that, again, the Big Bang was such a massive explosion that it generated energy that is still moving through our solar system today, again, even after, what was it, 13.7 billion years ago. So again, uh, energy, cosmic microwave background radiation, and the fact that there is energy moving equally in all directions shows that, again, there was one massive explosion at the center, and then again that energy is still moving throughout the universe. Then the Big Bang Theory describes how the expansion and cooling of the universe over time could have led to our present universe of stars and galaxies. Again, currently it's our best scientific explanation based off the expansion of the observable universe. So what we can see, we can tell it's expanding, based off the evidence we have. Again, the Big Bang Theory is our best explanation. Again, as time goes on, I'm sure there will be more people trying to add, subtract, modify, whatever. Because again, variations of the theory continue to be proposed and are being tested with new observations. Again, this is probably one of the most, again, out there, and not out there, I guess one of the things that's kind of most up for debate, based off of there could be one piece of evidence that someone picks up on. They could completely alter it, or they could just shift it slightly, or say, yep, this is in fact true, look at how much this supports our Big Bang Theory that we currently have. But again, no one was around, again, all those billions of years ago to monitor it and see it directly. But again, based on the evidence that we have, this is our best explanation. And then again, kind of talking about the age of the universe here. So since we know how fast it's expanding, again, we can infer how long it's been expanding. If you traveled backward in time, all of the matter in the universe would be at its starting point 13 to 14 billion years ago. And so using kind of our microwave background radiation, that's led to more precise age when now we've kind of been able to measure it more directly. Again, our estimated age of the universe is 13.7 billion years old. Again, that's based off of, again, our current things that we can observe right now. Again, we think we have a pretty good handle that that the universe itself 13.7 billion years old. Again, Earth around 4.6 billion years old. And so the last again, a thing they kind of mentioned is something called dark matter, which, again, I'm not going to pretend to be an expert on dark matter, and I've done as much research as I can on it, but it's kind of another one of those things that's kind of really, you can't observe it directly, so it's kind of hard to really have a full grasp on what it is. So dark matter cannot be seen directly, but its presence can be detected by observing its gravitational effects on visible matter. So this would definitely be something you need to know. Again, how do we know what the dark matter is there? Because we can observe it affecting visible matter. So to have a gravitational force strong enough to reverse the expansion, there must be sufficient mass in the universe. So to keep the expansion, because again, there are some, so the reason why they say that, because there are some galaxies that are moving towards us that appear to be on that blue spectrum there. So there has to be something working against the initial energy from the Big Bang. Because if there is less, then this amount of mass in the universe will continue to expand forever. So again, the universe is expanding, but there is something that's kind of slowing that down. Where am I at? Yep, there you go. So much of the matter in the universe cannot be seen by astronomers, and this is called dark matter. Again, it's matter that does not give off radiation. Galaxies like ours, they believe, may contain as much as 10 times more dark matter than visible matter. Again, may contain, again, just by looking at kind of some of the effects that we can see things moving. Again, like I said, there are galaxies that are moving towards us, so there's got to be strong gravitational pulls coming from somewhere. We might not be able to see this matter, so it's known as dark matter. There has to be something causing those galaxies to move inward. Again, there are many unanswered questions about dark matter. Astronomers don't know what it is made of or how it is distributed throughout the universe. We just know that much of the mass of the universe may be composed of dark matter. Again, it's something that we really don't know. We just kind of, again, using some indirect evidence there. In the past few years, astronomers have discovered that the rate of expansion of the universe may actually be increasing, so maybe there's more dark matter on the outside there that's kind of pulling things outward. Galaxies appear to be moving apart faster now. Galaxies appear to be moving apart faster now than expected. Should we say moving? Again, they appear to be moving faster, more than what we had expected. Again, the reason for this is uncertain. There's a mysterious force called dark energy is theorized to be causing the rate of expansion to increase. So again, maybe on the outer fringes there's things pulling outwards. If the expansion is accelerating, it's likely that the universe will expand forever. Again, this section there, again, a lot of uncertainty. You could try to research on your own and make your head hurt kind of like it did mine. But okay, that's it for this video. Let me know if you have any